Hi everyone, welcome to the Ultrasonic Kit for Arduino tutorial series. How's everything going? Today we'll learn an awesome device, servo. It is a gear drive motor that can rotate to a desired degree within 0 to 180 degrees and then stops precisely in the position. If you'd like to make something move as you want, a servo is the best choice. It can be controlled conveniently and the control is the least difficult. There are various types of servo. You can just try one as you like. First, let's look at its experimental phenomenon. We can see the servo rotates from 0 to 90 degrees with one pulse every 1 second, and then back forth. The rotation repeats consecutively until the servo is powered off. Now let's see what components we need for the experiment. The sun from the Uno board, a USB cable, some jumper wires, and a servo. A servo is generally composed of the following parts: case, shaft, gear train, an adjustable potentiometer, DC motor, and a control circuit board. Servo motors have 3 wires: power, ground, and signal. The power wire is typically red and should be connected to the 5V pin on the control board. The ground wire is typically black or brown and should be connected to a ground pin on the Arduino board. The signal pin is typically yellow, orange, or white and should be connected to a digital pin on the board. As for the servo we use here, the red wire for power, brown as ground, and orange as signal control. Servos are controlled by sending them a pulse of variable width. The length of the pulse will determine how far the motor turns. When the servo is commanded to move, they will move to the position and hold that position. If an external force pushes against the servo while the servo is holding a position, the servo will resist from moving out of that position. The detailed principle may be a bit difficult. In this experiment, you only need to know that we can control the rotation degree of the servo by code. In this experiment, the sun from the Uno board sends out PWM signals to the servo, and then the control circuit in the servo receives the signals through the signal pin and controls the motor inside to turn. As a result, the motor drives the gear train and then motivates the shaft after deceleration. The shaft and adjustable potentiometer of the servo are connected together. When the shaft rotates, it drives the pot, so the pot outputs a voltage signal to the circuit board. Then the board determines the direction and speed of rotation based on the current position, so it can stop exactly at the right position as defined and hold there. It may sound a little complicated, but just try to digest it and practice will help you with the comprehension. Okay, now let's build a circuit. Hook up the orange wire to pin 9. The red to 5V. And gray to ground. The circuit is completed then. Now the coding part. Open IDE. Define the header file. You can go to Sketch, import library, servo, or type in include servo.h to achieve that. But remember to type in a space between include and servo.h, or there will be errors during the compiling. Now let's first see a few frequently used statements for the servo function. Attach. Define the pin on the sun from the Uno board for the servo. Only pin 9 or 10 is available. Write. Define the rotation angle of the servo, ranging from 0 to 180 degrees. Read. To read the angle, you can take it as to read the value of the last write command. Attached. To check whether the parameters of the servo have been sent to the pin it connects to. Detach. To separate the servo with the pin. The pin, which is pin 9 or 10, can also be used as one for PWM. Please note that the format of the statements above should be servo name.statement. You can name your servo as you want. For example, my servo.attach9. Here the name is my servo and the statement is attach. In this experiment, we'll use just the first two statements. You may explore the rest yourself, or they may be used in the subsequent experiments. Okay, now continue the coding. Create a servo object, a name, as my servo, to control it. Define pin 9 as the pin for the servo. Set the original position of the servo as 0 degree for rotation. Delay 1 second. The following part is to make the servo rotate from 0 to 90 degrees and then back forth, and every 1 second it pauses for 1 second. The setting for each specific angle will be quite similar to each other, so you may follow me in the first setting and then learn to do it yourself for the rest. In this part, a servo write statement is used. As we mentioned above, servo here should be the name you gave to the servo, which is my servo in this case. So type in my servo.write and then the angle. Set the rotation angle of the servo to 15 degrees. Wait for a second. Set it to 30 degrees. Delay 1 second. Set it to 45 degrees. Delay 1 second. Set it to 60 degrees. Another 1 second. Set it to 75 degrees. A second. Then set it to 90 degrees. Wait for a second. Then make it rotate backwards. Set it to 75 degrees. Wait for another second. Set it to 60 degrees. Delay 1 second. Set it to 45 degrees. Another second. Set it to 30 degrees. Delay 1 second. Back to 15 degrees. Another second. And then set it back to 0 degree. Delay 1 second. Since I only wanted to rotate to 19 degrees at most, I set it so. You can change it as you like. You can set it like 135 degrees, 180 degrees, or other angle as you want, within the range of 0 to 180 degrees. Then compile the code and download the sketch. Now check the results. The servo rotates from 0 to 90 degrees with one pulse every 1 second, or you can say between every 15 degrees, and then back forth. The rotation repeats without termination until the servo is powered off. Maybe the effect and the cause spark the interest in making things yourself. If it does, why not hesitating? Imagine you can control something. You can make it move as you want. That's really cool and wonderful. Unpack your tools and start doing it, then you'll get joy and fun. As usual, for any questions or suggestions, do come to our website www.sunfounder.com and have some fun here. See you next lesson. Bye!